More than 8 hours of printing. Over 18 kilograms of material. Printing material that is beyond the capabilities of this printer. This isn't just another review like the ones all over the internet. This is my review, from which you will find out if buying the Prusa Core One Plus in 2026 still makes sense. Before we get started with the video, I guess I should say a few words. The printer was sent to me for this review by Prusa Research. However, no one at the company has any influence over the content of the video and no one is paying me for it. But seriously now, I really did receive the assembled printer from Prusa Research for review purposes and they really have no influence over the content of the video. Besides, I should have finished the review a long time ago, but so much happened between 2025 and now. At the beginning of 2025, I got married for the second time and my third daughter was born. After my previous divorce, I had to give up my 3-bedroom apartment in Prague and move into my current wife's apartment. After the birth of our third daughter, we realized that 5 of us simply wouldn't fit in a 2-bedroom apartment, so we started looking for a house. I will save the story about finding the house we eventually found and the problems we had to deal with for another video. This review originally started as a review of the Prusa Core One. Over time, the printer has been upgraded to the Prusa Core One Plus version, but we will talk more about that in the video. I wanted to start this review like a typical run-of-the-mill review, showing you how I unboxed the printer and what's included in the package. I wanted to show you how I pull the printer out of the box using some very clever designed paper handles. How I install the touchscreen onto the rail that's held in place by magnets. And how I peel off all that ugly protective film from the printer which protects the transparent polycarbonate panels from scratches. I filmed the process of turning on the printer for the first time where a guide Joseph walked me through the whole process of getting the printer up and running. I wanted to show how I use a mobile app and NFC to send the Wi-Fi login credentials to the printer. I wanted to show how I edited this printer to Prusa Connect, a remote 3D printer management system developed directly by Prusa Research. But I figured that would be terribly boring and a waste of time since the internet is already full of that kind of stuff. After setting up the printer, I printed almost everything that was on the included USB drive. Here you can see some of the first prints, but I don't have much to say about them. The keychains had holes in the letters due to the nozzle size, but otherwise they were fine, including the version with filament change during printing. The spatula model looks beautiful, but the bottom and top layers don't tell us much about the print quality. However, printing was a necessity as I couldn't afford to use a competitor's spatula on the Prusa printer. I also printed the included Benchy board, which was available on the USB drive in 2 high-speed versions. One took 14 minutes and followed the speed test guidelines for printing this board. The other took 8 minutes, used 3 grams less material and was really all about speed during the print. On the bow and sides of both boards, there are visible imperfections in the layering, which are due to rapid printing and insufficient cooling. While printing these little boats, I noticed how nicely the printer was able to dance around. Since both of these boats are examples of speed rather than beauty, it's very hard to say much about them. Still, I would say that for their print time, they both look damn good. Next, I chose this plate, which is used to test overhangs and cooling strength. I printed the model with both the printer door closed and open. No matter how closely I look, I can't see any significant difference between them. On the version with the door closed, which is on the right, a small imperfection is occasionally visible. But otherwise, the overhangs are handled perfectly and the print looks exactly as it should. Then I printed this alpaca. The print looks incredibly good, so I will give you a moment to take a look at it in complete silence. Alright, that should be enough. To be honest, I would really have a hard time finding anything to criticize about this print. The second to last model I had ready to print was this lighthouse. The print is almost flawless, with the only minor flaw being occasionally color shifts caused by the print speed. You can occasionally see filament strings on the staircase, but it's nothing a lighter can't handle. You can even place one of the printed boats on it and give it at least some purpose, other than just collecting dust. The last model I had ready to print was this model of a rocket engine. Yellow probably wasn't the best choice, but I had already run out of the Galaxy Black that came with the printer and I just happened to have this spool on hand. Since the entire print took more than 19 hours, I decided to run the print in a closed printer to minimize noise. Unfortunately, this decision brought a problem in the form of insufficient cooling. This is particularly evident in the upper part of the rocket nozzles, where imperfect connections and overhangs are visible. On top of that, I ran out of yellow filament during the print, so I had to use yellow filament from a different manufacturer. Unfortunately, it seems that in addition to the different shades of yellow, the nozzle collided with the print as it returned to its original position. Otherwise, I have to say that this print ranks among the best I have ever made. That concludes the section of printing files from a USB drive. I have tested a lot of different types of materials on the printer, which you can currently see on the screen. What you see is just a fraction of the materials I used for regular printing after these tests. During the printing of these materials, I had no problems with anything except for the adhesion. For ABS, ASA and some others, the Dimafix spray helped me with adhesion. With polypropylene and flexible TPE, I solved the adhesion issue by purchasing a print sheet for polypropylene directly from Prusa and the problems were over. For nylon, I tried glue sticks to increase adhesion, but in the end, I also bought a special print sheet for nylon from Prusa. I have separate videos for both of these special print sheets and you can find links to them in the description below the video. I received PPS AM230 filament from Spectrum. As you can see, the material requirements are beyond the capabilities of this printer. Still, I told myself, well, it will somehow work out. It took me half a century to heat the chamber to 60 degrees C and the print bed to 120 degrees C, but I finally managed it. The printer was pushed to its limits, but in the end, I managed to print this material as well. But take it with a grain of salt. To print all of these materials, I used the high-flow brass nozzle that came with the printer. Materials containing any additives tend to be abrasive and should be printed with a hardened nozzle. After printing these materials, a brass nozzle can no longer guarantee its diameter and consequently print accuracy. Later, I bought a new nozzle and a hardened nozzle as well. Actually, I bought several different nozzles right away. From all the materials shown, I printed not only clothespins, but also other things. Many of them ended up in the hands of friends, family, or my daughters at school and preschool. That's why I can only show you a few of them. As you can see, the printer did a damn good job in all cases. Of course, I had some failed prints while using it, but in most cases it was my fault. For example, when you forget supports or choose the wrong material. Or when, while printing ASA, you try to save fallen supports and by constantly opening the door, you create a draft inside the printer. I was most disappointed by my repeated attempt to print a bird feeder from ABS, which kept cracking even with filtration and cooling turned it off. But something tells me that the material was to blame, since the same print from ABS Plus by Devil Design printed absolutely perfectly. However, I had the most problems with the MMU3 extension, but I will tell you about that later. I also printed my own tolerance test using the 0.2mm balanced print profile. All the cylinders fell out of the model except for one, which indicated a tolerance of 0.1mm. When I pressed on it, it also came loose, indicating a tolerance between 0.1 and 0.15 millimeters. You can see that the cylinder was held in place in the model by just a few strings of filament. When I tried moving it back and forth a few times, the space around the cylinder suddenly became completely sufficient. I also checked the dimensions along the x-axis, where the print was 0.18 mm smaller. In the y-axis, the print was 0.2 mm smaller. You might be wondering why I am showing you prints from the Core One version when this video is mainly about Core One Plus. When upgrading to the Plus version, the printer did not gain anything that could affect print quality. In the package was a new filament spool holder which supports the new dry box from Prusa. Also, there was a new filament sensor which now handles elastic materials better. The package also contained parts that, together with the new firmware version, enable automatic opening and closing of the ventilation grill. And then there is also this plus symbol sticker. Unfortunately, by itself it has no impact on the printer's performance or print quality. Let's take a look at the printer itself. The printer's frame is made of bent steel. This means the printer is a bit heavier, but its construction is very stable. Just to give you an idea, the Prusa MK4S weighs just 7 kilograms despite its size. The Prusa Core One Plus is slightly smaller, but 3 times heavier. Interestingly, the recently introduced Prusa Core One L is larger, but lighter. This is achieved by using lighter aluminum for some parts of the printer. The Bambulab P2S, a new competitor, is even lighter. Despite its dimensions, it weighs only 14.9 kilograms. This is achieved through a combination of a large amount of plastic and a few metal parts. But back to steel. Steel has one amazing property. Thanks to its iron content, it's ferromagnetic. In short, it means that magnets stick to it. Thanks to this, we can add lots of accessories to the printer using ordinary magnets. Like this handy tool for removing nylon rivets or this HEPA filter holder. But there is a lot more on printables.com. So it's up to you to decide which model catches your eye. Now let us take a look into the printer chamber. This bar will slightly obstruct the view as it contains the LED lighting for the interior space. In the printer menu you can adjust the brightness of the lighting and the behavior of the lighting according to certain conditions. For example, under what circumstances the brightness should change and how strong the lighting should be after the change. Thanks to this, you can set the light to turn off when you are not actively working with the printer and to turn on after opening the door or after some activity. If you take a closer look at the interior, you will surely notice that the printer is asymmetrical. The reason is that the nozzle on the extruder is not centered. That's why the print bed is shifted more to the left, and as a result, the recess on the left side is smaller than on the right. During the development cycle, the company noticed this and realized that a filament spool could be placed on the right side. After a few modifications to the printer's design, this space was later optimized into the form we see today. The printer is compatible with flexible steel sheets of the same dimensions as those used by the Prusa MK3 and MK4 models. You can therefore use them without any problems. The build volume of the MK4S is 250 by 210 by 220 mm, whereas the build volume of the Core One Plus is 250 by 220 by 270 mm. This means we can use 10 mm more print area along the y-axis and print 50 mm higher. The print bed heating system is the same as in the Prusa MK4 series with just one minor difference. At the bottom of the heated bed is a colored LED strip that indicates the printer status. You may recognize this from the Prusa MK4, where this strip was located below the display. The color of this strip changes depending on the print status. Out of curiosity, I measured how quickly the build plate heated up to 60 degrees C from room temperature. I took the measurements with the printer door closed, but the ventilation grill open. it took less than 1.5 minutes to heat up to 60 degrees C. Here you can see the thermal camera footage while heating the bed to 60 degrees C with the top cover of the printer removed. I like that the printer also tries to heat the corners around the screws. The printer uses the same extruder as found on the Prusa MK4 series printers. The only difference is that the print cooling fan has been moved to the back of the extruder. This gives you a better view of the nozzle. The printer comes with a high flow brass nozzle. Replacing it on the printer is very easy. Just loosen the two screws on the left side of the extruder and unscrew the nozzle while it's cold. To make replacing the nozzle easier, I recommend printing a tool to help with the process. I should also add that the maximum adjustable nozzle temperature is limited to only 290 degrees Celsius. Before every print, the printer performs calibration of the X and Y axis with an incredibly annoying banging of the print head against the ends of the axis. The print bed is calibrated by tapping the print sheet with the nozzle. Therefore, there should be no problem printing on any print sheet. Unfortunately, during testing, the print sheet calibration failed several times, even after repeated attempts. At the rear of the printer, you can see the stepper motors that drive the X and Y axis. One step for both of these motors corresponds to a rotation of 0.9 degrees. Therefore, 400 steps are required to rotate the motor axis 360 degrees. This allows the printer to print with a high level of detail. Between these motors are two very powerful fans that remove warm air from the printing chamber. The speed and therefore the noise level of the fans can be adjusted in the printer menu. It is therefore possible to print PLA with very risky overhangs while the printer is closed. Cool air from the surrounding area flows in through the ventilation openings with a sliding rail. With the Core One, the printer prompts you to manually open or close the ventilation grill at the start of printing, depending on the type of filament used. With the Core One Plus, the ventilation grill opens and closes automatically at the start of printing via the movement of the print head. Between these fans is a temperature sensor that measures the temperature inside the chamber. The print chamber is heated only by the heat that rises from the heated bed. Thanks to the narrow space around the print bed, the print chamber should supposedly have no problem heating to 55 degrees C as stated on the manufacturer's website. So I decided to test it under the same conditions under which the print chamber is preheated at the start of printing. After more than an hour using only the print bed heated to 115 degrees C, the chamber only reached 50 degrees C. After more than an hour and a half, when the temperature was stuck at 50 degrees C, I stopped the test. Fortunately, you almost never need this temperature at the start of printing. During printing, the movement of the print head helps circulate the heat inside the chamber, speeding up the heating process. During the material testing, I managed to heat the chamber up to 62 degrees C. The Prusa Core One L uses fans under the print bed to speed up the heating of the print chamber. I decided to use the print cooling fan to speed up the print chamber heating. Just park the print head in the middle of the print bed, 30 mm above it, and set the print cooling fan to maximum. Thanks to this, I reached a temperature of 50 degrees C in the chamber in an incredible 18 minutes and 52 degrees C in a total of 20 minutes. Unfortunately, I never managed to reach 55 degrees C. Once the printer reached 52 degrees C, it announced that the print chamber was heated to the required temperature, which in my case meant the end of the test. If the airflow through the ventilation opening isn't sufficient and the door sensor is turned off, you can open the print door. The door is made of polycarbonate, so it shouldn't be damaged even with rough handling. Since it is plastic, not glass, you must clean it with non-alcohol based cleaners. You will notice this when you take the printer out of the box thanks to the label stuck to the door. For example, I use this anti-static cleaner on TV screens and monitors. There is a sensor on the print door that pauses printing if the door is opened during a print job to prevent potential injuries. This is useful, for example, in environments where people or children who are unfamiliar with the printer are present. Unfortunately, each such pause leaves noticeable marks on the print in the form of missing material. If necessary, the sensor can be disabled in the printer menu. If you don't like the way the door opens, you can move the hinges from one side of the printer to the other. The print bed moves along the Z-axis using 3 motors with integrated trapezoidal rods. Unfortunately, these motors are connected in parallel and are controlled by a single stepper motor driver. The leveling of the print bed is accomplished through a simple but effective method of pushing the print bed to the bottom of the printer. The printer has 2 filament sensors, one at the filament input of the printer and another one directly in the extruder. Both sensors can be turned off in the printer menu. If you disable the filament sensor at the printer input, you will have a really fun time when you run out of filament during printing. That is because it will remain at the print head and you will have to fight your way there to be able to pull the filament out. If only there was a simple way to remove the top cover. The printer parts are made of Prusament PETG and Prusament PCCF, which is Prusa's carbon fiber reinforced polycarbonate. You can find out which parts are made of which materials on the prusa3.com online store, where you can purchase not only printed replacement parts for this printer. A USB disk serves as a storage, which is inserted into the touchscreen display. The display serves as the main control element of the printer. Now, let's take a look at the brain of the entire printer, which is the X-body motherboard. In my case, it is controlled by an STM32F427ZIT6 microcontroller. I've already described this motherboard in detail in my video about the Prusa MK4. So, if you are interested, I recommend checking out that video. You will find a link to it in the top right corner and in the description below the video. Since the Core One required the integration of multiple components, Prusa Research decided to develop a new expansion board. It is controlled by an STM32H503CBU7 microcontroller. Most connectors are already connected and their description speaks for itself. I will therefore focus only on those that I found interesting. There are 2 connectors at the bottom. One is used to connect the MMU3 unit and the other is used for communication with the X-body motherboard. On the left side, there is a USB with power delivery support which powers the camera. According to the information available to me, it should be possible in the future to communicate with the camera through this USB port. The top row begins with a connector labeled EXT. In the schematic, this connector is designed for use with an external door sensor and an external filament sensor. On the right side of the board, there are 2 connectors labeled PUB-CAN, which stands for Prusa Universal Bus CAN. The printer also features a LAN port and a Wi-Fi module for connecting to the internet. The printer also has an NFC antenna, which is hidden under this cover. Thanks to NFC, device's credentials can be sent to the printer. According to my thoughts, in the future, this NFC antenna will also be used for reading parameters from new spools with NFC Open Printac. Another major plus, in my opinion, is the support for resuming printing after a power outage. That's something many printers still can't do these days. Performance quality is another matter, but it's still true that some print recovery after a power outage is better than none at all. I have already said something about noise defense, but I haven't shown you anything yet. That's why I have prepared a demonstration of several different scenarios in which I measured the printer's noise level. Now, I will let you listen to the sound of the printer printing for a moment. As you can hear, with the fans turned off, the noise level is tolerable. Unfortunately, this is a condition that you will only hear about with materials do not require cooling and heat or fumes removal from the chamber. When printing with PLA, you will want the print chamber to be cooler so the fans will run faster. When printing ABS or SA, you will mainly want an active filtration system. Fortunately, it isn't that loud. Overall, I find the noise level tolerable, but I wouldn't put this printer in the bedroom. We haven't mentioned anything yet about the remote control of this printer. The printer itself offers Prusa Link, a minimalist web-based control interface built right into the printer. You won't be blown away by this interface's features, but it's better than nothing. If you are looking for nearly full-featured remote control of your printer, then you will want to check out Prusa Connect. In addition to accessing files on the printer, you also have access to files stored in the cloud where you get 1 GB of space for your print files. You can expand this space with a Prusa subscription, which not only gives you more space, but also access to premium features. You also have a print queue here, which I consider a huge advantage over the competition. You can easily schedule prints several days in advance and simply confirm on the printer that it's ready for the next print. There is also a print history, a preview from the connected Wi-Fi camera, and various statistics which are available to you for only 90 days. Speaking of remote printer control, I must mention the Prusa mobile app. It's like a nicer and more streamlined mobile interface to Prusa Connect. In the printer detail view, you can see its status, print queue, and even the ability to perform certain actions with the printer. There is also a section where you can view the live stream of the connected camera and adjust its parameters. There is also mobile access to the printables.com website, which is an online database of 3D models for 3D printing created directly by Prusa Research. This will probably be the first place you look after purchasing your new Prusa 3D printer. Some models come with prepared print files that can be sent directly to the printer connected in Prusa Connect. Unfortunately, most models either don't have these files prepared or have them prepared for a different material than what you have in your printer. This is where the slicer comes into play, which allows you to prepare the print files for your printer yourself. You can use the online slicer EasyPrint directly on your mobile device. Its huge advantage over the competition is that on printables.com you can find multiple models and print them all at once. According to the latest information, Prusa Research is considering releasing EasyPrint as open source to the entire world. Let's now take a look at the accessories and extensions that are available for purchase with the printer. First, we will take a look at the nozzles for the extruder. The selection is nice, but it's completely unsuitable for me. If you want a high flow harder nozzle, you only have one option to choose from. Otherwise, you have to decide whether high material flow or nozzle durability is your top priority. Another accessory we will look at is print sheets. It took me less than 200 hours of printing and I knew I would need a new print sheet. Since the print sheets are identical with the previous generation of the printers from the MK series, I was able to start using the satin print sheet from my MK4S. The only thing I had to accept was different edge marking and missing text about Core One. The eShop offers complete sets of printing plates for this printer. Yes, the price is a bit higher, but these print sheets are really worth it. I myself purchased additional print sheets for printing polypropylene and nylon. I have separate videos about both print sheets on my YouTube channel. You can find links to them in the video description. For those interested in multicolor printing, Prusa has developed several versions of the filament feeder known as the MMU3, which supports up to 5 filaments. While testing the new version of the MMU3 on the Core One Plus, I had to intervene in the printing process far more often than I could have imagined. It is probably the only material changing system that has ever required me to intervene and solve problems so often. When the system worked, the prints were really good and it was a joy to print. Unfortunately, I spent more time troubleshooting than actually printing. That's why I was also glad that at Prusa Research they decided to take multicolor printing in a different direction. You have probably figured out that I'm talking about the new index from Bontech. On the Core One, it was officially introduced at the Formnext Trade Fair in Germany back in November 2025. Just before finishing this video, this product was finally released for sale. Unfortunately, again with a very long delivery waiting time. If you are at all familiar with DIY projects, be sure to check out the Prusa GPO hacker board. With this small board, you can trigger various actions in the printer or respond to various actions. Probably the most common use for this board is to create time-lapse recordings of the print. I have a separate playlist about this smart board where I show how these videos are created. You can also find the link in the video description. You can also purchase an accelerometer for the printer, which is a sensor that measures vibrations caused by the movement of the print head. Thanks to this, the printer can measure these vibrations and adjust the parameters to compensate for them. The result is a smoother surface, sharper details, and the ability to print faster without sacrificing quality. I don't understand why this accessory isn't built directly into the print head, just like it is on the Prusa Core One L. The same can be said about the camera, which is already installed in the Prusa Core One L right from the factory. With this printer, however, it is an accessory that must be purchased and installed separately. The camera offers live streaming via a local network and the internet. You can view it in the mobile app, in the Prusa Slicer, and of course directly in Prusa Connect. The camera features infrared lighting for night vision and interval shooting to capture images of the print. The images are saved to a micro SD card, which unfortunately is not included with the camera. After cancelling the time-lapse recording, a full HD video file will be created from the captured images on the card. To ensure the recording has the correct name, you need to start saving frames only after starting the print you want to record. Out of curiosity, I also purchased the camera and installed it step by step according to the manual. At first I thought it was a waste of money. But as is usually the case with Prusa, their products get better over time after you buy them. After the latest firmware updates, the camera's video runs beautifully, clearly, and most importantly, smoothly. If you don't want to use the camera, you can simply remove it from the printer or turn it off in the printer menu. Last but not least, it's definitely worth mentioning the advanced filtration system, which features a HEPA filter with 99.9% efficiency and activated carbon granules. The result is an effort to eliminate both particles and unpleasant odor. This filtration is almost a necessity when printing materials such as ABS or ASA. When they are printed, styrene is released, which has a sweet, pungent odor and causes a burning sensation in the nose, throat and eyes. In the short term, it causes headaches, dizziness and fatigue. Long-term inhalation can damage the nervous system and increase the risk of more serious health problems. That is exactly why it is important to print these materials only in a well-ventilated area and to use appropriate filters. I tried printing a holder for a HEPA filter from a vacuum cleaner, but the result wasn't very satisfactory. Without air extraction behind the filter, particles and odor were bouncing off the filter and the odor eventually escaped from the printer into the space anyway. Various holes in the printer body contributed quite a bit to this. Eventually, I reached a point where I decided to go with a ready-made solution and I purchased a filtration system. Installation took literally just a few minutes. I've printed around 7 kilograms of ABS and ASA, and since installing the filtration system, I haven't noticed even a hint of odor or dizziness, as was the case with my version of the HEPA filter. Before I tell you about the price of the printer, I would like to touch on a few things I like and a few things I don't. It seems to me that Prusa Research does things only halfway. I would start with the design, which I really like. What I do not like though is that the design creates spots where small pieces of filament love to hide. Fortunately, the community has already noticed this issue and solved it in their own way. I also don't like that the power button isn't just hidden on the back of the printer, but is also awkwardly placed completely out of reach on the power supply. Fortunately, the community has found a solution for that as well. I really like the option to move the door to the other side of the printer, which is something many printers can do. I also like that the printer can turn off the lights when idle and turn them back on when there is a user activity. What really bothered me though was that the door sensor on my already assembled and calibrated printer wasn't working as it should. When I closed the door, the switch didn't engage. This turned out to be a simple fix, but it shouldn't have been an issue with this printer since it came fully assembled. I like that you can hide an entire filament spool inside the printer body and it doesn't get in the way anywhere. However, if you place two printers next to each other, you need to leave a larger gap between them, otherwise you cannot access the filament of one of them. Thanks to the community, you have the option to print a side panel that allows you to move the spool inside the printer. I also like that thanks to the metal frame, you can attach various accessories to the printer without needing screws. For example, various tool holders or printer accessories. So it's no problem to have a spool of filament enclosed in a box with a desiccant on one side of the printer and tools and print sheets on the other. Unfortunately, because of its metal construction, the printer is very heavy. I like the speed and simplicity of changing the nozzle by simply loosening two screws and unscrewing the nozzle from the code printer. What I don't like is the fact that the printer comes with a brass high-flow nozzle. Nozzles are not cheap, and if you want a high-flow hardened nozzle, you don't really have much choice. Moreover, cleaning it is done by tapping it against the print bed instead of using a silicone brush like most competitors do. The community has also figured this out, and Josef himself even confirmed in a message to me that the printer will soon have something similar as well. I also don't like that the hot end and firmware limit the nozzle temperature to 290 degrees C. Especially when I consider competing printers that offer higher temperatures for less money. For the price of a smaller 3D printer, you can purchase an upgrade in the form of a hot end with an easily replaceable 400 degrees C heating element. With it, you will be able to print with high temperature materials such as PEG-CF, PPS-CF and PPS-U, as well as many others. At the time this video was being produced, this accessory was still not available for purchase. I really like that there is an accessory like the Prusa GPO hacker board. You can use it to create really nice time-lapse videos or control various electronics components. It really depends on your skill level, but it does require some knowledge of electronics. What I really don't like is that the board can only perform actions that the printer already knows about. For example, it can signal a layer change because that's a hard-coded value in the G-code of the print file. However, it cannot react to, for example, the end of the filament or a printer error. Another great feature of this printer is the filtration system, which far exceeded my expectations. What I don't like, however, is its incredibly high purchase price. This ventilation system is bolted to the printer. So, if you need more cooling in the print chamber, you will need to unscrew this filtration system from the printer. When printing is paused, the print moves away from the print head while the filament is gradually retracted from the nozzle. When you click the resume printing, what you see right now will happen. So, if you are printing materials like ABS or SA, you will be forced to open the printer and enter the contaminated area. I could also point out the openings all over the printer through which odor and material particles can escape. If you have the previously mentioned filtration system installed, these openings will instead be useful for drawing clean air into the chamber. I like that the printer has two filament sensors and can detect the end of the filament at the moment when it can still be pulled out of the printer. Unfortunately, with soft elastic materials, it is really a big problem to push the filament through these sensors all the way to the nozzle. At the filament entrance to the printer, they are trying to solve it using this switch, which releases the filament passage when switched. While inserting a very hard nylon filament with carbon fiber reinforcement into the printer, the internal PTFE tube fell out. It runs from the filament input sensor all the way to the filament sensor of the print head. Fortunately, thanks to the printer's repairability, it was a matter of just a few minutes to fix. Which reminds me, I damaged a part on my old dusty Prusa MK4S while moving. The printer has been sitting in the corner for a while now, and because of the Core One Plus, I don't have much time for it. Again, thanks to how easy Prusa printers are to repair, it was just a matter of printing one replacement part and spending a few minutes moving the fasteners. Unfortunately, it once happened to me that a too soft TP filament got tangled in the extruder and the extruder had to be disassembled. The repair only took a few minutes again. The Prusa mobile app combined with printables.com, the Prusa Connect cloud service, the Easy Print online slicer and the camera inside the printer is exactly the combination I have been missing with Prusa. Being able to pull my phone out of my pocket, select different models, place them all on a single print bed and remotely send them to the printer to print is incredibly addictive. What really bothers me about the app is the fact that you cannot skip the printing of an object through it. So if a similar situation arises, your mobile companion will be completely useless. Skipping the printing of an object is only possible from the printer menu, in Prusa Connect and in Prusa Slicer, which internally uses Prusa Connect. Even though the printer arrived fully assembled, I noticed as soon as I unpacked it that the M3 to 10 screws were missing from the Z-axis bearing housing. I also could not overlook the buzzing noise from the printer when moving the Z-axis downward, which I first heard right after unboxing the printer during the initial Z-axis calibration. Speaking of things I don't like, I have to mention MMU3. This is the only multi-material system where I had to deal with some kind of problem almost every single print. Or rather, I can't recall a single print with the MMU3 right now where I didn't have to solve a problem. I'm actually quite disappointed that this is the only offerable multi-material extension for this printer. Unfortunately, the index by Bondtech for this printer costs almost as much as a new Prusa MK4S. It's also important to keep in mind that the delivery date keeps getting pushed back and no one actually knows exactly when the product will reach customers. Moreover, thanks to the long development period, similar products from competing 3D printer manufacturers are already appearing. And probably the last thing I really do not like is the price of the printer. Unless you manage to order the printer during a sale, you will have to dig deep into your pockets. I understand that manufacturing in the European Union and primarily in the Czech Republic costs something, but many people do not have their salary in golden bricks. Now I will do something that the people at Prusa Research will not like me for. I have a printer in my cart that comes with a camera, filtration, a hardened high-flow nozzle, an accelerometer, and a fully assembled MMU3. Now, take a look at the price and decide for yourself whether you think it's reasonable and whether you are willing to pay that much for this printer. For the same price, you can get several printers from different manufacturers, mostly from China. Such as this flagship model called H2D from the Chinese company Bamboo Lab. For almost the same price, you will get a larger print area, printing from two hardened nozzles with a temperature of up to 350 degrees C and a heated chamber up to 65 degrees C. The combo package also includes the AMS2 Pro unit, which is an automatic 4-material feeder with a built-in filament dryer and an NFC tag reader for spools. Using cameras and artificial intelligence, the printer can detect printing issues and notify you of everything. If you plan to use the printer and its slicer without an internet connection, you will be getting a beast of a machine with just a few limitations. If you connect the printer to the internet, you will have to accept the fact that all your data will go through Chinese servers. Moreover, in recent weeks, there have been many controversies surrounding Bamboo Lab which cast a very bad light on the company. Prusa Research is a European company that complies with open source licenses, and your data will never reach Chinese servers. So it's up to you to decide what's more important for you. At the time of finalizing this video, the printer had logged over 800 hours of print time, and I had pushed over 18 kilograms of material through the nozzle. As you can actually see in this overview, which I created after I found out that I would not be able to show you statistics on Prusa Connect older than 90 days. Yes, I printed mostly PLA. The printer did not come with a filtration unit, and I only had the basic print sheet and a brass nozzle, which I later fixed by purchasing an Obsidian high-flow nozzle, a filtration unit, and Prusa PP and Prusa PA print sheets. Thanks to the print sheets, I was able to print various types of nylon, polypropylene, and flexible TPE with almost no issues. Thanks to the filtration unit, printing ABS and ASA at full capacity was suddenly no problem at all. The Prusa Core One is a really good and very cleverly designed printer. Unfortunately, due to its price, it ranks among the more expensive products on the market and is being overwhelmed by cheap competition from China. When you buy a Prusa printer, you are not just buying a printer, but also a ticket into their entire ecosystem with premium support. It is actually similar to buying a product from Apple. I own an iPhone myself, and I know very well that for the price I paid for it, I could have gotten a much better phone running Android. Yet I decided to go with an iPhone again because I am happy with them and Apple products have never let me down. Prusa printers, their firmware and their slicer are open source, and on GitHub you have access to their source code and wiring schematics. So it is no problem to see exactly what the printer does and where it sends your data. These printers are easy to repair and modify. Their support works damn well, and they genuinely try to help you. You do not wait days or weeks for a response, but minutes or at most hours, which is something you cannot say about the support from Chinese brands. I can't tell you whether or not you should buy this printer. That decision is up to you. I personally own printers from both Prusa and other brands. I have a special connection to each printer, and each one suits me for different purposes. So it's entirely up to you whether this printer meets your needs and whether you can justify its higher price. Plus, the folks at Prusa Research occasionally surprise us with new improvements.